right. So question 3. Camilla, do you want to read it?
Yeah. Cool. So, so it says what requirements must be checked when conducting a hypothesis test comparing two means with independent samples. Mark all that apply. So A, right?
Yes.
No.
And I put C and D.
What about B?
I did just A and B.
I can't remember if this is one I got wrong.
Yeah,
Yeah.
it's just A and B.
Oh, yeah.
Yeah,
No,
B,
you're
right?
right. Because the bottom. Yeah. No, you're right.
Okay.
So the test statistic for a hypothesis test comparing two means with independent samples is a t-score. Yeah?
No.
Oops. What is it again? The test statistic for a hypothesis test comparing two means with independent sample is a t-score. Yeah.
Okay.
Cool.
Two samples are independent if B.
B.
I put B, yeah.
Okay, sweet. Okay, for the next 6 questions, use the data files. This data represents a simple random sample of dental bills at the dentist's office in Idaho Falls and a dentist's office in Rexburg. Let be the mean bill at the Idaho Falls office and let sigma 2 be the mean bill at the Rexburg office. Perform a hypothesis test to determine if the mean bill at the Idaho Falls office is less than the mean bill at the Rexburg office, which means we have the null hypothesis sigma 1 equals to sigma 2. And alternative hypothesis sigma 1 is less than sigma 2. Use level of significance of 0.10. Okay, I'm gonna download that really quick. Dentist office.
For this one, Keith,
Yeah.
I could not figure it out. I kept getting like some random. I put down 3. I think was my answer last time.
On which one? Number 6?
But I'm like, that can't be right.
The degrees of freedom from SPSS is 37.996.
Okay, let me see what I put.
Okay, so Idaho Falls people are gonna be the first group, right?
Mm-hmm.
Okay, let me do that. Okay, cool.
Okay, so I
I'm
guess
so tired.
my first time I put 37.982. Why did I get that?
So degrees of freedom, I got 21. Oh no, never mind. I did it. Sorry, my bad. Okay, I'm doing it again. Actually, I was doing the dependent test.
I mistyped my use of my level of significance.
So degrees of freedom, I got 38, right?
It's
round to 3 decimal places.
Do we have to round it? Oh, okay, cool. So yeah, so 37.996.
Yep.
Yeah. 7. What is the simple standard deviation for Rexburg?
I got 206.637.
That is what I got.
So that's variable 2. What is the question again?
The standard deviation up for Rexburg.
206.637.
Yes.
206.637.
What is the test statistic? Round to the 3 decimals. 0. Where'd it go?
Wait. Question is, what is the test statistic? Okay. So minus 0.434.
0.434.
Yeah.
Yeah.
So negative 0.434.
Yeah.
That is what I got as well. So, and the p-value.
The value is 0.667. Oh, yeah.
Did you say
7?
0.667?
Yeah.
That's what I got.
But remember, this isn't a two-tailed sigma, so you got to divide by 2. So it's 0.333.
Oh yeah, because this is smaller than. Is that how it is?
Mm-hmm.
Right.
Smaller than, right? So it will be 0.333.
Yeah.
Oh, okay.
10, what is the correct decision based on the evidence? Fail to reject?
Yep. Okay. 11. Suppose instead that you had used the alternative hypothesis, sigma is different or not equal to sigma 2. What is the correct decision based on this evidence?
B, right?
B. Yeah.
What is B? Insufficient reason in this one. Yeah.
Okay. So we'll let you download that information, Camilla.
Oh yeah, freshman dinner.
Uh-huh.
That's funny. Freshman dinner. Okay. I'm opening it up. So students from Utah. So what does it say? So what? Okay, I'm pasting it right now.
You're fine.
So is it remember? 16 Utah students. Okay, so Colorado. So Colorado is the first variable, right?
Mm-hmm.
Plug in the things in. Okay. Okay. Hold on.
You're okay.
Okay. So what type of test are we doing? Is that not equal to or less than? Or?
It looks like sigma 1 equal to mu 2, or sorry, mu 1. Is that mu? That's mu. Mu 1 equals mu 2, right?
No, but that's the null hypothesis.
Right. What were you asking for?
What is the type of test?
Oh, sorry. So let's see.
I don't know.
So mine ended up being wrong. I haven't written down it yet. I did a 2-sample t-test. Which didn't work out.
So probably it's not equal to, right? Because it says you suspect that freshmen from Utah cooked dinner for themselves a different number of times than freshmen from Colorado. So it's not saying less times or more times than Colorado. It's just different. So it's just so the type of test would that be not equal to? So two-tail.
Yeah. So B on 12 is what I chose.
Is that right?
Yeah. So on 12, that's correct. The type
Okay,
of
so not
test
equals.
didn't work.
So, okay. So the test statistic, what do you guys get for that?
I put negative 0.867. That's not correct.
So what I got,
So
I
that's
got,
what I put, Keith.
What'd you put?
8.67. Or sorry, 0.867.
You didn't do the negative, you did the positive?
Yeah, but I got it wrong.
Yeah, so I did the negative one because there was both negative and positive, and it's still wrong.
Yeah.
So I don't know.
so I have, what do you get again, Haley?
Sorry, at 0.867.
I got negative 0.845.
I guess we'll try that then.
That's what I got, negative 0.845.
So you got like 0.45.
So negative 0.845, that's what I got. And then for the p-value, I got 0.411.
411.
Yeah.
Okay, that's what I got.
Okay. So according to these, we failed to reject it, right?
Yes. Because
Because it's bigger.
yeah, because that one's bigger.
So determine a 95% confidence interval for mu1 minus mu2 and estimate for the difference between mu and mu2. So determine the margin of error for this 95% confidence interval. Okay, how do we do that again? Do we margin of error? Oh,
Hey guys, I gotta mute my microphone. I got a crying baby. I'll be right back.
okay.
Okay.
Hey, Keith.
Yeah.
So to find the margin of error for 95% confidence interval, so I grabbed the t, which is negative 0.845, right? And then times the square root of the standard deviation of the first sample over the sample size plus standard deviation of the second sample over sample size.
For the margin of error,
yeah,
t-score times your standard deviation divided by the square root of your sample size.
Yeah. So since we have two samples here, I think we have to add them up. So we do the standard deviation over the. Well, I'm looking at the formula right now, and it says sample of the first sample standard deviation over first sample size plus second sample standard deviation over second sample size.
I missed that. That's why.
Oh, you missed that one?
Yeah.
So yeah, so we have to do. Yeah, so that's so standard first sample. Yeah, first sample. So
What did
it will be.
What did you get for your standard deviations for Utah and Colorado?
Okay, so for Utah, which is so Colorado is my variable 1, right? Let me write that down here. Colorado and then Utah. my variable 2. So for Colorado standard deviation, I got 4.517.
Okay, good.
Okay, so I got
I'm not sure.
4.517 over the sample size of Colorado, which is 10, plus Utah standard deviation, which is 3.420 over 12. So how it's looking, I have my negative 0.845 times the square root of 4.517 over 10 plus 3.420 over 12. Does that make sense?
Yeah.
I think that's how you do it. Let's see. Let's see what I get. So the first questions that we were working on, do you get those right, Keith?
I got right all the way up until 13.
Until what?
Till 13.
Oh, okay.
You just did 13 in Excel, right?
Yeah, I'm doing everything in Excel right now.
Yeah, and you got, so on 13, you got negative 0.845.
Yeah, and then the p-value, I got 0.411.
Yeah. Do you know, does the two t-scores and average them?
Wait, what is it?
Do you know if Excel just takes the two t-scores and then averages them?
I will guess that. Yeah. Let me see what it says in here.
Because I added up, because I have the same standard deviation as you, but I have different t-scores.
Yeah, I think so. For oh my gosh, this is a super complicated formula. I don't do it. But yeah, so I click on t-score and it's taking into account the sample size, the mean and the standard deviation of Colorado and Utah.
Okay.
So I'm not exactly the process, but that's what it's showing me.
Yeah. Because
Okay, let me do.
I did the average of my two,
And
it was still wrong, so, or at least different.
Do you do the equation that we were working on for the margin of error?
I was working on a different one. So let me go back to our
This is
t-score.
long. I hope I get it right. So do you have everything for? Do you have all the
I think
numbers
so.
for the equation?
Yeah, you're using negative 0.845, correct?
Yeah. Okay, so for negative 0.845 times the square root of 4.517 over 10 plus 3.420 over 12. The answer I'm getting negative 0.725. That's what I'm getting. Let me see.
7.25?
Yeah, so I'm getting negative 0.725. That's the margin of error. But let me try to do this in a different way to see if I get the same answer. Because sometimes the calculator is kind of tricky. Do you get the same, by the way?
Try again.
Yeah, I'm getting the same, actually.
Okay. calculator, I got
So
the same. So I don't know.
You did?
Yeah.
Sweet. Let's just do that. So negative 0.725 for question 16. Haley, if you're listening, we got negative 0.725. Then for the lower bound, I got negative 5.147.
I wonder why SPS is so much different this time. So I got both those wrong because SPS does it all up just like Excel. Except for 17, I got negative 4.996, and the upper bound I got 2.063.
So for the upper bound, I got 2.214. What do you get again?
I got 2.063.
Hey, that's close. So yeah, you get it wrong, right?
Mine is wrong.
I got 2.214, and then for the lower bound, what do you get again?
On the lower bound, I got negative 4.996.
Negative 4.996. That was close too. I got negative 5.147. So I don't know.
Negative 5 point what?
So I got negative 5.147.
.147.
Yeah.
And then so on the upper, you got 2 point what?
2.2414.
2
Sorry, guys.
2.214. Hey, welcome back.
Sorry.
Hey,
Sorry,
it's
you
okay.
guys on 17.
Okay, one more time. 2.214.
14.
Okay.
Yeah.
Yeah. So I don't know what it is because they're so close, but SPS wasn't correct.
Okay, let me try to submit it to see what I get. I'm gonna submit it right now.
So I missed 8.
So I just got one wrong. I got 16 wrong. That was it.
What did you put for 8, Camilo?
8 minus 0.434.
Oh, that's why. Dirt. Okay. I didn't put the minus.
So here's
So I got everything right except for 16, which is determining the margin of error, which is kind of
here's the funny thing on that one. The first time I did it, I couldn't figure it out. I knew what I had was wrong, so I left it blank. And here's what it told me in the feedback, because it'll give you feedback.
See the answer? That one? Yeah, I got it too.
It says the answer in SPSS is slightly lower than in Excel. So it says the answer given is the average between the two results.
Okay, so wait, how much do you get for SPSS?
I couldn't get it to do it. I did it because I used the numbers that we have on, and I used my calculator, so that's why I have the same answer as you.
Yeah, no, exactly.
So
the first time you didn't get it right.
And so then this time it's still wrong, but
Haley,
I don't get what else to do.
Haley, do you get that one in SPSS?
So I was overhearing what you said, and the first time I took this quiz, I put in what Keith's original answer was.
So blank?
Put in blank? I thought you put in a different answer.
No, I left it blank, and then the next time Camilo and I put in negative 0.725.
Okay, because that's what
we
I
used the numbers.
I did it on Excel.
Yeah. Well, it's not. I'm not gonna worry about it. It's just 1 point.
I'm not either. I don't know what else to do with it.
Yeah.
All right.
Well, good job, guys.
All right. So we will see you guys next Tuesday.
Tuesday, 8:30.
Sounds good.
Thanks, guys. See ya.
Have a good week.
See
Bye-bye.
you.